So basically there's two parts to this afternoon session. I'm going to talk at you a little bit to start off with. I'm going to tell you about the world of soft electronics. Now, soft electronics isn't a real term. It's a term I've made up, basically just to encompass all of the different types of textile and flexible and soft kind of circuitry. My day job is in hardware. I work for Crowd Supply, which is owned by Mouser Electronics. So basically I work for Mouser Electronics. That's why I'm here in the US. But in my personal work, I like to do a lot more experimental electronics than PCB type stuff, although I do lots of PCBs as well. So in order to talk to you about this stuff, I want to give you an example of some of my work as well, so that you can see how I came to this field and why I'm interested in it. But I also wanted to talk about some of the different genres of soft electronics. I'm going to dive most deeply, and our session today, our workshop today, will be on electronic embroidery, which is basically, we're just going to learn to use conductive thread, the basics. It's going to be simple stuff. So electronic embroidery 101 is going to be the focus of the workshop, but I'm also going to talk a little bit about that. Not just the simple stuff that we'll be doing today, hands-on, but I will show you some more advanced techniques as well, as you might want to start working with microcontrollers or blah, 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 blah. I'm also going to be talking about the world of e-textiles, flexible circuitry, and what I mean by that is stuff like this. This is the flexible PCB that I made. It's made of Kapton tape instead of fiberglass. I'll be talking a little about soft robotics, and then I'll finally speak a little bit about the concept of softness in electronics, material choices and feelings and that kind of stuff. So wait, there's two screens that I got to move on. So that's broadly what we're going to be talking about. We do a whistle-stop tour of all the types of soft things that you can find in hardware, just to give you a taste of what exists and what's possible, and hopefully inspire you to use it as an alternative material in your work going forward. It's a useful skill to have. Let's start here. Okay, so my job now, as I said, I work for Crowd Supply, which is part of a giant electronics organization here in the US. But before that, I spent many years as a writer and a professional maker. I had a regular column on hardware for Make Magazine and various other magazines as well. And I also wrote a bunch of books, including this one. This is a still from my book called The Crafty Kid's Guide to DIY Electronics. This was a book that I decided to write on basic electronics, taught through the medium of craft. I didn't set out to write a book. When I set out to write this book, I wasn't particularly excited by sewable electronics as much as I am now. I'd done some work with it before, but it had been more for my own, personal interest. But doing the research and workshopping for the soft electronics chapter of this book really made me notice a few things, but especially the switch in my audience. So researching this book was the first time I started teaching basic concepts of electronics through the medium of craft, rather than wires and boards, as is more traditional. I'm not going to go too deep into the pedagogy of this, but I will say that my experiences running workshops teaching basic electronics skills through a standard through-hole learn to solder or my first robot type kit was completely different. So it's the same skills. We're learning how to build a simple circuit, parallel circuit, series circuits, how to light up LEDs, work with sensors, yada, yada, yada. But the medium, here we are. But the medium changed the demographics and the vibe of my workshop completely. So same skills, different medium, completely changed the feel of it. And that was the first time I was like, this is interesting. So after that book was published, I worked on another project, this project here, that put one of my first glove, in fact, that put that technology in the context across. So this is the Minimoo. This is a DIY wearable instrument kit that I designed for Imogen Heap and P. Maroney, which is the British Adafruit, basically. So the basic concept of this kit is that kids wire, code, and sew this glove. They make the whole thing together, right? But workshopping this project, again, gave me lots more anecdotal evidence about how to, excuse me, what's going on here? About how people interacted with craft-based things differently. Let me just bring that down. So basically, these kinds of kits, appealed to teen and tween girls a hell of a lot more than your typical robocar thing, which I think when you stop to think about it for 10 seconds should be extremely obvious. And also, interestingly, in the workshops that I did when I was developing this project, all the kids who were really good at sewing got a head start on the classmates who were good at coding. So it actually kind of helped even out and give some kids like a confidence boost at the beginning before they got onto the electronics and the code. So it was actually pretty interesting. Anyway, less anecdoted, but that's basically, those are the two big projects that I worked on that I had to spend a lot of time workshopping in classrooms, and both of them had very, very interesting effects. Anyway, that's kind of an aside, but I thought it was that was my route into being interested in this. So when I wasn't making books and writing education materials and doing stuff like that, so when I was making stuff for myself, right, so not for clients, I would always make instruments. So this is when I wasn't making things on demand for other people, I would tend to make instruments or sound making devices using experimental materials. This is not using anything sewn. This is using a rod that I got from an architectural store, but this is a 30 pin capacitive device. It's a spider, and it's generative. Like, you play it like a harp. It's very interesting creature kind of thing. But I've made loads and loads of these different things. So my personal work has always been about making experimental things with unusual materials, and soft materials are one of the types of experimental materials that I like to play with. So that's a broad introduction to my work and how I became interested in it, writing, making products, and then my own personal hardware work. So I'm going to move on now to the jumping off point for most people to this kind of work, which is electronic embroidery. So when most people think about electronics, they're normally thinking about like stiff fiberglass printed circuit boards, or like wires and boxes. But the wires and the traces on printed circuit boards are all just paths for electricity to move along when you think about it. So this is just a different way of providing a path for the electricity to move around a circuit. By choosing different types of materials to create our circuits, we can make all sorts of exciting and unexpected electronics. Just to get a feel here, how many of you have made a simple circuit before? Good, excellent. So I don't need to tell anyone anything about this. So basically, as you can see in this slide, we've got a very simple circuit. We have got a power source, we have got a component, and we have got some wires. Now, they happen to be sewable, but you could make the same circuit on a breadboard, on a PCB, yada, yada, yada. It's the same. It's just the medium that's different. But the thing that's interesting here is the stiff fiberglass is replaced by this supple felt, and the copper tracer would be replaced by a curvy, flowing stitch. So there's actually lots of really interesting things you can do with this. And I will say, as an aside, if you're doing this in future, like these small embroidery hoops are really great when you're starting out, because you can check your mistakes. Particularly if you're doing slightly more complex projects, I would highly recommend you get yourself a couple of these. All right, so this is the major thing that I want you to take away from this. This is conductive thread. This is a slide full of all the different conductive threads and one non-conductive thread that I could find lying around my house. Conductive thread is the starting point for most people who get interested in soft electronics. So I'm going to spend a little bit of time here guiding you through some of the basics of choosing and using conductive threads, and plus some of the problems that you're probably most likely going to run into. And during the workshop, I will be reiterating the basic problems will come up. So before I start a new project that uses conductive thread, I've got to ask myself a few questions, right? Where is it going to be situated? Is it going to be on my body? How flexible it's got to be? Am I going to hand sew it, or do I want to use a machine? If it's a machine, can I go in the top and the bottom thread, or is just the bottom thread okay? Like, how are you going to connect it to the components? Does it need to be soldered? Do we, what are the there's many mechanisms for connecting thread. So there's lots of different design considerations that you've got to ask yourself. But broadly, let's go on to the next slide. I'm going to come back to this slide to show you how they relate. But these are the broad types of thread that you will come across in your journey at the beginning. So you've got, these are not scientific names, these are just categories that I have given, having worked with lots of different types of threads. So you've got this kind of, one of the more common threads you'll get, the cheaper thread, is this like fluffy type of thread. And you can see that in the center piece here. It's got a little pink thing, and then you've got this fluffy thread in the middle, running through the middle. Basically, when you think about a wire, this fluffiness is a problem. Because if it's fluffy and it's close to another wire and two bits of fluff touch each other, you've got a short circuit, which means that your circuit is not going to work because it's not going around where you're trying to get it to go around. So you've got to watch out for fluffy. So basically, the way to so here's a good example actually of the fluffy thread. You can see all of on the picture there, you can see on the bobbin, you've got loads of stringy bits. So that's what you've got to watch out for in this fluffy thread. There's a fix for this. Number one, just keep your paths a little further away from each other than you would necessarily. So don't put them too tight so there's no danger of the short circuit. So that's number one. Number two is when you finished it, you can give it a little spray with a fixing spray, or I just use hairspray actually, just a little spray and smooth it down, and it will keep those in place. So if you are using fluffy thread, just keep those stray threads away from each other. I don't use the fluffy type of thread that much, to be honest with you, but it is cheap and it is out there and the knots are alright. Now, the major type of decent quality thread you get out there is what I call a waxier thread. And an example of that is the ones in the spools here at the bottom and on the right-hand side, the two spools, the bobbins. And you can see here, even on the shadow, that there's no fluff coming off of that anywhere. So you don't have the same issue you're not gonna get a short circuit from flyaways on this kind of waxy type of thread. Now these waxy type threads are the threads that you're gonna get more commonly now because that's what Adafruit sells, and most people use Adafruit. And there is a problem with this thread. It doesn't have the same problems as the fluffy thread, but because it's slightly waxier and slightly stiffer, the knots will come undone, which is a huge problem for the longevity of your project. So basically, you can either use a dab of nail varnish or a little bit of hot glue to seal your knots and keep them in. I do have examples of. This is a very ugly example, but you can see. Can you switch to the? Oh, you did already. Okay. This is an old little sampler I did. This is just an old circuit playground. An old circuit playground. And some neopixels and an accelerometer here. But if I flip it over, I didn't have any nail varnish. So it's very ugly. That's hot glue that I used to seal the knots because this is the waxy type. This is 4 years old at this point. These 4 years old at this point. These knots definitely would have come undone by now. But here they are, and it still works. Here they are, and it still works when it's plugged in. So yeah, that's that. Definitely that's the waxy stuff. Yeah, just be careful with that. And it looks like it's done a good knot, but it's lying to you. So seal your knots. Waxy things, seal your knots. Then another one I want to tell you about, back on the slides if that's okay. So down in the lower left-hand corner here, you've got one of my favourite threads. This is a copper thread. On this slide, this is the only one on this entire slide that you can solder. This is by a German company called Karl Grimm, who currently, their website is down. And basically, a lot of these German companies you can, it's very difficult to reach them. But this is a fantastic solderable thread. It comes in silver, it comes in copper. They are strands of pure copper and silver that are spun together around a Kevlar core, which is why you can solder them. They are the only ones you can solder. However, the material properties of it are very annoying to sew with. There's no way you could put this anywhere near a sewing machine. It's extremely brittle. This is hand sewn only. So if you want to switch to the down camera, you can see, and I'll show you, I'll hand these around to people in the room. So this is something that this is an embroidered analog synth that I made. Which is done with this copper thread. And you can see it looks really beautiful. This was a real pain in the ass to sew. Not okay though. Not okay. It just breaks all the time. All right, that's done. And then, so Okay, so yeah, here we are, fluffy, waxy, copper, we've done that. So my two faves, I've said Adafruit, which is the waxy style, which is the, because it's generally available and you're not going to get short circuits. However, my actual favorite for really good stuff, and this is what we're going to be using today in the workshop, is Madeira HC. Now, I'm very happy to say that this slide is a lie now because it was perfect and not widely available, but it is now available. So it is perfect and widely available, kind of. It's an amazing thread, and it's actually been developed by Madeira, who are a giant embroidery company. They are not an electronics. They have nothing to do with electronics. This is their first ever electronics thread. And that's good because it means that it has been designed for the rigors of industrial manufacturing. I have seen this on an industrial machine, and it goes away like a machine gun. This is the only thread as well that you can use in the top and bottom of a sewing machine. So this spool here is $38, so it's not cheap, but it is the best. So that's the introduction to the types of thread you can buy and how to work with each of them. Any questions on the threads specifically? Look at my lovely picture. Any? No? Yep.
Where do you get them? Like, do you order online or?
Yeah. So for the fluffy thread, you can get that at Adafruit or Sparkfun. Ditto the waxy thread, they don't call it that, but you can see it from the pictures. And I call it, just because I've grouped it by behavior rather than, because that's useful. Copper and silver you get from Carl Grimm, that's K-A-R-L, Grimm, like the story tale, then, etc. And then the Madeira stuff, which I really love, right at the bottom of this slide it says Madeira HC. So you can't buy it from any second-party people, but now Madeira sell it direct. So you can buy it anywhere in the US and post it to you, which didn't used to be true. You used to have to ring up a lady called Kathy and ask her to send you some. Like, literally. They were always very perplexed because they're embroidery people, not electronics people. And they're like, what do you want that for? Anyway, so...
What is it called?
Madeira, M-A-D-E-R-I-A, HC, and there's two varieties, and I've got both of them with me today. Yeah, they're just a slightly thicker. Yeah, it's really, really good. You can get a giant spool of it as well.
Did you say you could use it in an embroidery machine?
Oh yes.
Oh,
yes.
I saw there is.
Oh yes, you can. This is the first thread that you can really predictably use it. Let me show you a picture of it. In the little sneak preview. Look at this. This is an industrial embroidery machine with this thread in it. And I watched this be made. It took seconds. These things go so fast. This is like proper. You can use it in an embroidery machine, you can use it in the top and bottom thread of a sewing machine, just like normal thread. It's amazing.
And then machines that you can use with the thread? Is there a limitation on the kind of machine?
I just use a normal Singer.
Wow.
I've just got some generic Singer, my first sewing machine. Whatever, it's just thread. It's literally just, if I was giving this talk 2 years ago, it would be different. But now we just have thread. It just works, which is great. So I'm very excited by that. So, practical tips. All right, let's move on to some very practical. So we've gone through threads and availability and so on, what they do. So let's have some practical tips about working with this thread. We've spoken about the intricacies of working with the different threads, i.e. the tips to, for the fluffy and the waxy and all that kind of stuff. But this advice now is generic to all types of working with thread. And these two things are, I would say, well, there's three problems that come up over and over and over again in my workshops. One is usually they put the battery in the wrong way round. That's problem is number one, the reason something doesn't work. And the other two reasons that things don't work are literally one of these two things almost always. So the first is connections. The picture on the right, we've got two images of a LED at the top, which is sewn on correctly, and an LED at the bottom, which is sewn on purposely badly. I mean, obviously, So basically, you can see the component at the top has been sewn on with 4 or 5 neat stitches holding the component in place, and also making sure that there's a firm electrical connection between the component and the wire. In the component on the bottom, we've just got 2 randomly loose stitches. This will not work because you need to have a proper connection. It's just the same as if you were soldering and you did a bad solder joint, you know? These are your solder joints, so you've got to make sure that they're nice and crisp and tight. So that's number 1, loose connections. That's, apart from the battery being in the wrong way around, this is biggest problem, number 2. And then the third problem that you'll look into, and this is why I say to use embroidery hoops if you're doing a big project to start out with, is dangling knots and loose ends. It's surprising how many people forget about the underneath of a piece of sewing, but that's often where you'll find all the things that are wrong with it. So if you flip your so basically any of these loose connections, they're going to cause the same problem as the dangling wires. They're going to create a short circuit. Does everyone know what I mean when I say short circuit? I want to, okay, please do, if there's something I'd say that you don't understand, then, you know, let me know. All right, so just check the underneath of your work so that there's not these loose dangly things. So connections, dangly things, battery the wrong way around, those are really the things that, the 101 things that you need to look out for. So the component on the right-hand side, this blue one, this is just an ordinary through-hole ceramic capacitor. And all I've done here, and we're going to learn this today as well, so you can make any component that is through hole into a sewable component using a pair of needle nose pliers. And I will show you that on the down cam. I will also, for those of you that are in the workshop today, I will come around and show you this. It's not super difficult, but I'll just show you. So you got that on the. So basically, you got that on an LED. So basically, as most of you probably already know, you have 2 legs. You have the long leg and the short leg. The positive is the long leg. So what I'm going to do is I'm going to take the negative leg of the LED into the jaws of my needle nose pliers, and then I'm just going to wrap them round the jaws of the needle nose pliers. Until I get a loop. I bend that loop slightly to make it parallel to the cloth that I'm using. And there I have a completely sewable loop just on an ordinary LED. And this works for capacitors, resistors, LEDs, whatever, okay? So, well, I'll say, I tested, in this particular example, I just twisted the negative first. So on the blue component there, it doesn't matter which way around it goes. It doesn't matter, but for the black component at the top and for this LED, it does matter which way around it goes. It's got a positive and a negative, and that needs to be hooked up to the power in the correct way. So the way I do that is, so once, I mean, for an LED, if you've got sharp eyes, you can tell from the top of the LED, there's one side that's flat, but the way I do it is, just for simplicity's sake, the long leg of the LED, which is the positive side, and the way I remember that is I add a little bit, is I put a little extra through the teeth of my needle nose pliers before I twist it round. And that way, instead of just a curve, I've got a curve, you know, a sewables. What's happening with my words today? They're just not coming out of my mouth in the right order. You'll not just have the circle, you'll have a circle with a pointy bit at the end, so you can see which one's the positive one and which one's negative, like nice and easy. But yeah. So that's all you do. It is literally as simple as that. It is when LED that is ready for sewing. Got that? All right, cool. You can pass this very badly, shoddily made example around, but I'll show you that in a minute as well. So that's how to make those. So I just wanted to say that that is how to make like any through-hole components sewable that way. That's one technique I wanted to tell you. And then the next technique I wanted to tell you is in the middle of this project, you can see there's a little brown rectangle that says stitch and glitch. And what this is a flexible PCB. I'm going to speak a little bit about flexible PCBs in a minute as well. But this is a very slim, very thin printed circuit board made of Kapton tape with copper traces. And what I've done here is I've designed this because to put chips onto embroidered electronics, there is a technique where you can, so for example, with this copper thread, you can solder individual threads of this copper to the individual legs of a chip, and then use that chip in your embroidery. And not only is that mega annoying, like I would consider myself a very good solderer, and I was very irritated by the time I soldered, it took way too long. So I decided never to do that again, and instead I designed this little PCB, and it's got a little dip chip socket on it. So if you flip it over, I've soldered 8 points, and then this chip just slots in and out. So I can replace it then if the chip burns out, rather than just having to throw it in my project. So yeah, that's another thing. There's not a lot of people who are using that yet, but yeah, just be aware that putting a chip onto a piece of sewable electronics, doing a flexible PCB, is a useful way to interface those two things. This is actually using capacitance as well. So the little pads here I've made just by sewing through. It's not particularly exciting. But I also, so that's the next, so making components sewable, making capacitive touch pads by sewing over them, and then making, putting chips on your stuff with flexible PCBs, worth knowing about. This is just an example to inspire you. This is not my work. This is part of a giant computer, actually. This is a working, programmable 8-bit computer that an artist called Irene Posh made. This is a very small close-up of it. It's very big in real life. And this is all made with embroidered gold and magnets, embroidered magnets as well. So each of those circles is a bit that gets flipped with the magnet, whether it's on the left or the right. I thought that was pretty cool. So just that. And then here is the, here is the industrial embroidery machine that I was talking about earlier. So one of the really exciting things about this genre of electronics is at the moment it's currently really maturing at a rapid pace. So it used to be much more of a niche technology that was championed by academics and DIYers and weirdos like me. But nowadays, new materials and new processes are definitely, so it's in industry now. These kinds of threads, they've brought this kind of idea into industry. So I was working with the folks at Microsoft Research just before the pandemic hit, and I was lucky enough to get to see this in action. It's a ZXK industrial embroidery machine. It's amazing. It sounds like a machine gun when it's going off. It's it's incredible. And not only, I'll talk you through a little bit what's happening in this image. So I believe you've actually been working with these already, the Circuit Playground Express, right? It's this Adafruit, my first microcontroller kind of computer. It's a great little board. But this was actually sewn in place by this machine as well. So and I'm saying they sewed in the pins. That's why they actually chose this, because they don't have enough accuracy to do something like I don't know, like a teensy or a piece of electronics where the pit for the holes are so small. But because the holes are a bit bigger, this can get in and out. So this was completely machine embroidered, the whole thing. This is actually a piano, like a capacitive touch piano with 12 notes. So yeah, the whole thing just very, very quickly just machine embroidered. Even the cable here was machine embroidered in place, which is wild, huh? They're pretty cool. I mean, there's still loads and loads of obstacles in the way for, this isn't in commercial clothing yet. We're talking about automotive industry. We're talking about medical industry, something where people are paying a lot of money for this kind of stuff. So that was pretty cool. Yeah, so basically, the interesting thing here is that the ZSK, who made the machine, and Madeira, who made the thread, they are industrial embroidery brands. They're not interested in like the tech. They're interested in something working and being working at factory speeds and working at, you've got to have factory quality. You can't have failures every 10 minutes. So you do have to. It has advanced a lot in order to be able to do something like this, but it's still not quite there yet. And this is kind of why as well. I'm not going to spend too much on that on this side of things because this isn't an industry talk. But when we're manufacturing traditional electronics, we use machines called like pick and place machines that take components from reels and then they put them on the PCB, right? And then it gets melted and it's all very lovely. But in manufacturing soft things, textiles, they also have similar things, not for components, but like beads and buttons and all that kind of stuff. So they have like, they don't call them pick and place machines, but they're similar to pick and place machines. What currently doesn't exist are components on spools that work with embroidery machines that have electronics on them. So we don't have, so these are experimental, what they call sequins, that are currently, like they're trying to manufacture these at the moment. So these are just LED sequins, but you've also got RFID sequins. We've got like all sorts of things being, like Bluetooth chips, antenna, like all sorts of stuff. So this is being developed. This is like very much cutting edge. This is experimental. Not super relevant, but I just wanted to show you what they're doing out there in the experimental. And this was the slide I wanted to come back to for the, when you had the different designs for the embroidery have different properties, right, electrical properties. And this is, you are absolutely correct. So these threads that we're using, they have different levels of resistance, of course. I think it's, for the Madeira, I think we're looking at less than 10 ohms per meter of resistance, which is, pretty great, but it's not the same as like bare copper. But this is an example of something that we'd call moss embroidery. Now, moss embroidery is a technique that you'd use to make chenille or like towels. So basically, you've got a substrate material, you've got your base material, and then you've got thread on your pointer needle. And it goes, and your thread goes in and out lots and lots and lots and lots of times, like creating these tufts, right? Like towels and chenille, you're creating all these millions of tufts. But when you do that with conductive materials, that greatly increases the amount of conductivity because it's the same thread. They're all electrically connected, the same thread in and out over and over and over and over and over again. That means you have incredible levels of conductivity and sensitivity in moss embroidered conductive thread. Now this is used a lot in automotive, but one of the big use cases, which I think is really interesting for this, is this exact picture is an electrode for medical use. So as the conductive fibers go into a body, so basically, what's this? So how am I going to explain this? Yeah, so basically, when you're getting electrodes onto your body in a medical situation, they go on with glue. And some people are very, very allergic to that glue. And some people will just rip them off. I'm thinking babies or people with mental illnesses who are not able, who are like, do you know what I mean? So these sensing technologies that are going on their body are not suitable for all of them. So something like this, this electrode, they actually sew these into form-fitting garments, so like baby clothes. So they'll put it in, and as it goes onto their body, not only is it not irritating, they can't tear it off, those fibers splay against the skin, picking up even more information. So these are very, very useful, and they're actually used both as inputs and outputs. So they take data, but they can also be used to deliver electrical therapy. So I thought that was pretty interesting. So yeah, that's not like sci-fi, that's real. So that's just, so yeah, and interesting, because of the thread's surface area, not only, it doesn't require any use of gel at all, none. So it's actually really great. Yeah, actually already in use, we like it. Okay, so that's a pretty deep dive into the basics of electronics embroidery. Now, I'm going to give a little whistle-stop tour of a few different other aspects of soft electronics, not in as much detail. I'm not going to go into how to work with the things, but I'm just going to show you what exists, basically. If there's anything that tickles your fancy in here, you can pick it up and run with it. But I'm just going to throw some cool stuff out there and see what you like. So let's talk about fabrics. So the term e-textiles is used very generically at the moment, so it's not particularly useful anymore. I'm using it here to refer to conductive materials that have cloth-like properties. You can find this also called conductive fabric, or often also EMF shielding fabric. There's lots of different choices. I'm going to share with you some of my favorite basic fabrics, but you can go out there and look for some other stuff. So a good one to know about, so Adafruit has a number of beginner e-textiles, but there's another website that I use called lessemf.com, which is which like a lot of tinfoil hat people use, you know? Funnily, there's quite a good intersection between people who are like, I don't want the government spying on my phone, I've got to, you know, cover my entire house in like conductive, in these fabrics, and you know, because they're paranoid. But that's great for us because we can just buy their stuff. Yeah, e-textiles, yeah, lessemf.com. It's surprising, that little intersection there. So here's the basic, two basic types of fabric is woven versus knit. Who knows the difference between woven versus knit? No? Okay, so I will explain that then. So the basic difference between woven versus knit is the yarn, or the thread that composes them. So a knit fabric is made up of one single yarn that is looped continuously over and over again on itself. So it's just one long thread. And we're thinking about this both in terms of physical properties, but also in terms of electronic properties as well. So it's one yarn going backwards and forwards. And the physical properties of a knit, because of the way it's done, it's stretchy in one direction, right? Stretchy in that one direction. But it still loops, knots, one thread stretchy. That means that it has different, because it's just one thing, and it's stretchy, it means that it's got different resistance in each direction. For this particular piece of fabric, you're looking at 46 ohms per foot across the rows, which is the stretchier direction. So all those knots going in and out, right? Lots more. But across the columns, the same distance for the foot would be 460 ohms of conductivity. So that's 46 versus 460. And that is because, as I say, a knit is comprised of a single strand of fiber that travels backwards and forwards across the fabric. So you should be very aware of that if you're ever using knit. The other type of thing that you're going to find more commonly is woven fabric. And in woven fabric, it's not just one yarn knotted, it's two yarns over and under. So what you're doing is over and under. That's woven, right? That's how to create knit. And in that way, because on the x-axis and the y, you know, like the two axes of the thing, because they're comprised of, you know, individual yarns at right angles to each other, you're going to have the same level of conductivity on both of the axes of this one, unlike the knit. So this particular woven conductive fabric has resistance of under 1 ohm per foot in any direction across the textile. And both of these fabrics are both from Adafruit. So that's the basic thing. I did want to, you know, it's important to know that there is a difference between those things electrically and not electrically. Oh, and this is a really fun material that I would recommend you experiment with. It's something called Velostat. It's a lovely little thing. Get yourself a sheet. You can cut it out with scissors. You can sew it. You can do all sorts of stuff. It's pressure-sensitive material, so squeezing it reduces the resistance. So it's great, fantastic for making flexible pressure sensors. So I've made a pair of meowing yoga pants out of this, but it's much less expensive than like off-the-shelf pressure or bend sensors. You just get one sheet and then you can cut it out as you like. You know, do the math, hook it up, and you've got a much cheaper pressure or flex sensor than you would otherwise. It's a really useful one to have in your back pocket. Just not useful for every project, but if you ever want to use pressure sensing in fabric, Velostat is your bay. That one, this particular, we can get it from different places, but this is from Adafruit as well. Love a bit of Velostat. And then I also wanted to give a shout out in fabrics to tapes. Now, tapes are great for prototyping. This is a harp cape I made for my neighbor in Berlin. So there's different types of tapes. I think the most common one that you find in this space for electronics is copper tape. You find that everywhere. It's quite easy to find. I do find copper tape is too brittle and finicky for fabric work, so I use this stuff, which is conductive. I forget what they call it. Like it's just conductive tape, right? Brown Dot Gadget sells it under the brand Maker Tape. I think Adafruit sell it as well, but it's very similar to. It's what I've used in this cape. So the individual lines, they're all conductive tape, and each of them corresponds to a different note on the harp. So you play it by playing like your wings. But that's the conductive fabric tape. Pass that around. This I find is so easy. You just like slam it on and you're done. You know, it's quite a fun thing for prototyping. It's excellent, and it also comes in a sheet, which if anybody has ever found how to buy this damn thing in this country, please let me know. I will buy you a pint, because I've never found anywhere that this is on sale in this country. So this is Maker Tape. This is exactly the same as that, but it's in a sheet, and you can use this on a CNC or vinyl cutter or whatever. So you can just make a printed circuit board straight away out of this, and it's like got backing on it, and it's got like it's essentially adhesive on the back as well. So I'll pass around the raw. That's the raw stuff, and that's really great adhesive. That works super well, and that works with a scalpel as well as a CNC, you know, or scissors. That someone gave it to me at a hacker camp, I'm afraid. I have not been able to source it in this country. Alibaba will sell it, I'm sure, but no, that is something somebody gave to me, and I've been trying to find it. If you find it, let me know. I'll buy some too. Huh? It's a conductive tape. It's an adhesive conductive sheeting, I guess. And another one I wanted to put in, this isn't a tape, but I have it here in my hand, so I'm going to tell you about it anyway. I'll show it if you want to show this. This is a pre-made set of printed conductive inks. I don't use this super much. It actually works. It's made by their conductors. It actually works. It's paint as well. So they make these sheets of conductive. This is conductive printed. You can cut these out. It's a pretty interesting little thing. Okay, so those are the tapes. I did want to put an honourable mention out here to something I don't tend to do. Where has it gone? No, I don't have it. I don't even have a slide for it, sorry. Oh, no, I do, here we are. So this wool-like stuff in the bottom left-hand corner, this is felting material. Felting is not a craft I've ever found myself doing. However, if it is your craft, if you're interested in trying it, you can get felting materials. That's kind of stainless steel wool, and apparently one felts by stabbing something repeatedly. It exists in conductive. I have not used it. I own some, I have not used it, so it exists. I wanted to give it a shout out in case other people wanted to use it. If you're interested in felting, I think there's a woman called Sam Topley. She does interesting, she actually does like she does pom-pom kits, like conductive pom-pom kits that make noise. It's really cool. Sam, S-A-M, Topley, T-O-P-L-E-Y. She's got an Etsy store where you can buy like DIY pom-pom musical instrument kits. She's just someone I know from the London hardware hacking scene, but she's delightful, and every time I go to an event, she's just there with these giant, noisy pom-poms. I mean, how can you not love that, you know? Anyway, so honourable mention to felting. Tapes are great for prototyping. I feel like we've done tapes. This is just a shout out for another talk that would be interesting. So it's only a 15-minute talk, but this is a really great talk by Dr. Anuradha Reddy, who is a postdoc researcher, some kind of academic something over in Sweden. And she did this talk called Yarn is Hardware. The name of the talk was called Naughty Hardware, N-O-T-T-Y hardware. Just a 15-minute talk about yarn as hardware. that was really interesting. And this is one of her projects. She made, this is a lenticular internet of towels or something she called it. It's like she crocheted this is a lenticular crochet, and then you can scan the QR code and it takes you to the instructions for how to make it. So it's kind of a fun little loop. Anyway, she does really interesting stuff, so I just wanted to throw her name out there. If you're interested in the more academic side of interesting hardware stuff, go and watch her talk. And then this is Cobacant, and this, if you take a photograph of any slide in my talk, this should be it. Cobacant are the maestros of this world. I was lucky enough to, so Cobacant is a studio in Berlin, run by two women who met at MIT, I believe, Hannah and Mika, and they run this like couture level electronic textiles. So this is, there's two things. Number one, I want to tell you about this really awesome piece that is on this slide. This is a custom made gown, a mourning dress. So in some cultures, you pay for people to wail for you. And this is a wailing dress. It actually wails. The silver embroidered spirals on the dress are all functioning speakers. And this, it's an incredible piece, and they all sorts of stuff like this. But they do these really beautiful, high-end, like really, really wonderful to look through their projects. But the reason I wanted to is not to show you their work, although that's very cool, is they also have a site called How to Get What You Want, and the URL underneath the dress there, the cobacant.at/DIY, is a little bit dated now, but it is basically the Bible for wearables. If you want to learn how to connect a four-pin thing to a piece of cloth, or it's got lots of different like techniques. So there's like just loads and loads and loads of techniques that you can scan through and take a look at all these projects that they've done. Just, hundreds. It's a treasure trove. So please, if you're interested in this, go away and look at this. It's really cool. All right, so that's eTextiles. Briefly, I'm going to swing through flexible circuitry. So as many of you probably will already know, so a normal circuit board, like the Circuit Playground Express that you've been working with, is made out of, like the base material, the substrate is fiberglass, which is this, tough material. But in a flexible circuit board, it's all the same. They lay down the traces and copper as the same. But instead of fiberglass, they use Kapton. With Kapton, in case you're interested. And that makes the flexible circuits, that makes the circuitry flexible instead of rigid. And another interesting thing about flexible circuitry is that when you're making a PCB, you have to consider where the drill goes. So there's a physical process, right? So you're constrained by where, your design is constrained by where the drill hits can go, right? So you can't have like really tight corners or so on. Flexible circuits have no such constraints because they are laser cut. So you can actually make some really interesting shapes with flexible PCBs. I'm not going to spend too long on flexible PCBs, but I do want to say, if you are interested in going deeper on this, there's a fantastic YouTuber called Carl Bajaga, and you can see his Twitter handle there in the bottom. This is actually his image as well. And he's done absolutely loads of really interesting experiments using flex PCBs. So if you are interested, please go and check out his channel. No, I'm not going to do any of this. We don't need to tell you about this. This is a project I made. It's on the desk, actually. This is a flexible vocoder I made using the flexible PCBs. But yeah, flexible PCBs, they exist. I mean, there are design constraints, but I don't feel like it's worth me telling you. If anyone here is doing PCB design and they want to ask me more questions about how to design for Flex, I'm very happy to go over that, but I will skip on for now. Come and ask me. So the last big thing I wanted to talk about is soft robotics, which is a very exciting, genre of electronics at the moment. This is a still from an artistic soft robot that these group of people in my home country of Wales make. So they make these giant installations. I first came across them at some hacker camps in the UK and then in Germany. And they make these big installations that are inflatable, these pneumatic giants, which are delightful. And I will tell you a little bit about that, but before I do, conventional robots are normally made from like rigid parts, which will make them a lot more vulnerable to to harm in certain situations from bumps and falls and so on. But it also means that they're very constrained in where they can and can't go. But the soft robotics scientists are experimenting with making robots from elastic and rubber and plastic and with designs that are often influenced by marine animals, like starfish and octopuses and worms. And these types of soft robots are generally more resistant to damage in certain situations, and they can wriggle past a lot of the obstacles that will impair a hard robot in the same situation. So this is an Octopus Bot, which you probably could have guessed. It's a squishy underwater robot, and it has 8 limbs that bend in any direction with a pneumatic control core. So basically, it's taking water and shooting it out. It's like it intakes water and then spits it out in various different ways in order to make it move, essentially. So this, what happens is, so basically the orange part of this octopus expands and fills with water, and then it jets out to propel itself forward, and that's the pneumatic motion. And then when you order it to crawl, it stiffens each of its limbs in turn, and then, so basically it can, by pushing water into and out of its different appendages, it can crawl forward. And it can shoot forward through the water using the mantle. And then interestingly, so the scientists who made this, they gave it an order to crawl underneath a dock, this tiny little space, and it just like pushed out all the water from its body and then wiggled through the gap and went through. So it was really, really interesting. And these are very commonplace in academia nowadays. Like there's lots of people doing a lot of research on soft robotics. And it's being used a lot in underwater, but also in space. There's a lot of soft robotics science in space, that's for damn sure, which is pretty cool. Anyway, soft robots, who doesn't love them? We love them. Yeah, and this is more the artistic side. This was pretty interesting, actually. So this one was made, like I controlled this with an Xbox controller. So just very briefly, the way that this is working is they sewed the body of this out of a material that holds air. So it's like a traditional kind of, parachute material or whatever. So they sewed the body, and then the vents, and then they fill the body with just a bouncy castle air pump, just that they bought off eBay, and then they control the movements of the body by opening and closing those vents. So the only things that are electronically controlled in this giant soft robot are the vents. But by manipulating those vents, it actually made an incredible, like, I've seen like 3-story high tentacles that these people have made, and they move so interestingly just by robotic control of like 3 or 4 vents, which I thought was really interesting. Food for thought, anyway. If you want to get into soft robotics, there's a few different things. This is an open source hardware board for experimenting with soft robotics. This is an Arduino based, so that you can control pneumatics using an Arduino. And this is programmable air. That's worth looking at, worth having a look at as well. So finally, oh good, I'm right on time, that's correct. Finally, I wanted to talk basically, briefly about the concept of softness in electronics and like why I might use softness in electronics. So there's lots of different technical reasons you might use these technologies, but then there's also, as somebody who has like their own personal practice of like hardware that I make, when I use a fabric, it's in order to have a certain effect, right? And by choosing different materials, you change the feeling of your electronics enormously. The same electronics on a PCB are very different when you look at them when you interact with them on a piece of material. So this was a piece that I made a couple of years back. I didn't bring it today because I cycled here, but it's a tentacle that wraps around my body that's plush, and it's embroidered through the center with silver. And when I stroke it, it purrs. It's a very simple reaction. But I made this when I was really depressed. and really anxious. And I wanted something that would comfort me. And it wrapped around my body, and then I just filled my ears with this like super bassy purr based on like a reaction to my touch. And it sounds silly, but like actually it was extremely comforting. It was a really lovely experience, both to make it and also to hold it, to use it, you know. So, but if that same functionality was done in a box, it wouldn't have had the same effect. You know, that material choice changed that project completely. And what's this? Oh, no, we're not going to watch that. No. This is the same glove as right back at the beginning. Where did it go? This. So this is the children's glove I made. Remember, like classroom, you know, how to, you know, like sew this glove. We make a chip tune using our hands. It's all very wholesome, you know, all very Taylor Swift. And then this is a version, exactly the same hardware. Exactly the same hardware. This one, and there's almost exactly the same code, but this time it was made in a elbow-length leather glove. And I made this to control one of my herd of robot unicorns, obviously. But I made a series of different robot unicorns and a series of different gloves and different materials, and it was really interesting to see like how you felt in different. So like the ones with the like blue felt, it felt like really fun, and with this like an elbow length fitted leather glove, I was like, die. You know, like I felt like some kind of like evil overlord, or you know, like, or it was very sexy as well. I got lots of DMs on Twitter because of that. I was like, ooh. But you know, just literally the material choice, just from felt to leather, completely changed the feel of the project and how people reacted to it as well. So that was a very brief, obviously, what you put your electronics inside matters, you know, what it does, it has a big impact. And then finally, I wanted to, this is my bonus slide of the different microcontrollers and single board computers that I tend to use. So my favorite beginner microcontrollers are the Adafruit Circuit Playground Express, which I believe that you've been using, and the BBC Microbit, which is used a lot in schools, you know, younger schools. They're very cheap. And then when you go on a bit further, so those are useful. Those are great for beginners because you can use block code, because you can do all sorts of, you know, there's lots of sensors and there's lots of things on board, right? There's a lot of things that you can do without having to leave the ecosystem of your board. You don't have to solder things onto it. You can just start doing stuff, right? So those are definitely my top two learning boards, definitely. As you get to more advanced stuff, so I'd say that my favorite board combination for making embedded instruments specifically is the Bella and the Beagle board. So the Beagle board is a single board computer, it's open source hardware, and the Bella is a cape for it, which is excellent for embedded music. And I've put, if you're interested in that side of things, Becky Stewart has a great GitHub with Leading Zero. She's got lots of really interesting code examples for that. And then also any kind of boards, or Solder Party is some Swedish guy who makes interesting boards. But the reason I put him up there is because I really like castellated edges. So castellated edge is like one row of normal holes and then one row of half holes. And they're often used for breadboard prototyping, but actually they're also really great for sewing. So anything with castellated edges is great for sewing because you've got that little hook to make your stitches nice and neat. So those are that one. And then finally, there's a couple of made-to-measure boards. So there's I think they're up in Canada, I think, this Make Fashion. They do boards that are designed specifically. They're more like LED stuff. So if you're the kind of like wearables person who's like really into putting LEDs all over yourself, Make Fashion is really good. Oh, actually, if you're really into putting LEDs all over yourself, you should look up, he's local actually, just over the water in Vancouver, Washington, Pixel Blaze. Excellent board, like definitely my go-to LED controller these days. And then also a big shout out to the lily pad range from Leah Buckley. Now, Leah Buckley was one of the avant-garde, one of the people before me interested in this, and she was pivotal in making all of this kind of ecosystem happen. And she designed the lily pad range with SparkFun, so they're worth looking in. They're the Arduino-based stuff. So like lily pad is in the Arduino ecosystem, Microbit is either block code or MicroPython, and the Circuit Playground Express is, of course, CircuitPython. But if you're more used to the Arduino ecosystem, then LilyPad is good for you. And that's it. That's the talky part of this afternoon session. I hope I've given you like a decent whistle-stop tour of all the different types of softness you can find in hardware. Are there any, before we move on to the actual making stuff, were there any immediate questions? Yes?
In the fabric, is the resistance stay consistent and destructive?
No, it does not. And people use that as a project. Yes, well, I mean, so some materials have a stretch and some of them don't, but the knit, yeah, it will change as you move it. Yeah. Any other immediate questions, or should we move on to making a little sparkle heart emoji? That's what we're making today, by the way. It's very exciting. Well, let's move on to the workshop, because you can always chat to me as we walk around.